In the giganticness of the universe, mankind has simply started to investigate. Notwithstanding our obliged appreciation, we've frequently estimated on the presence of life past Earth. Here and there contemplating whether we're singular in the universe. Yet, a noteworthy situation transpired with the appearance of our first interstellar guest, Oumuamua, an element not at all like any we've experienced, starting marvel about the obscure domains past our planet. Eminently, the regarded astrophysicist Neil deGrasse Tyson as of late revealed never-before-seen declassified pictures of Oumuamua, mixing interest in who sent this extraterrestrial emissary, the importance of the Earth impact, and its association to Oumuamua, setting out on an excursion into space's profundities. Directed by astrophysicist Neil deGrasse Tyson, we reveal the riddle surrounding this particular interstellar drifter. In 2017, an uncommon find utilizing the Pan-STARRS 1 telescope by Robert Warwick acquainted us with an object hurtling towards Earth. The presence of Oumuamua touched off an intense change in our comprehension of space and its perpetual possibilities. In spite of its notoriety, our information on Oumuamua has remained insufficient considering public interest. Neil deGrasse Tyson revealed previously secret, exceptionally classified pictures of Oumuamua through his expertise, revealing its significant influence on our nearby planet group. Previously digging into the secrets and buried in these long-covered pictures, it's urgent to see the value in the enthralling pith of Oumuamua. On October 19, 2017, the Hawaii-based Haleakala Observatory made a fundamental perception of what showed up to be a comet or space rock. However, it was later recognized as the first interstellar article identified inside our nearby planet group. Other than dust grains, its unconventional circle and quick speed suggested its extraterrestrial beginning, earning it the name Oumuamua. To comprehend its structure better, cosmologists have contrasted it with comparative nearby planet group objects like the space rock 25M143 AWA, which the Hayabusa shuttle visited in 2005. While AWA shared some features with Oumuamua, the interstellar visitor's extraordinary prolonged extents and non-appearance of a tail set it aside. Adding to the mystery is Oumu's exceptional acceleration, similar to a bike suddenly accelerating without accelerating. Entering our planetary group from above, it came astoundingly near the Sun previously, going on beneath the planetary plane, keeping an unprecedented speed of around 196,000 miles per hour, indicative of huge dynamic energy. This speed is unrivaled by any human-made object, highlighting Oumu's extraordinary excursion through our nearby planet group. The high speed of Oumuamua has prompted a speculation suggesting that it could have begun from a double-star framework. This hypothesis suggests that gravitational interactions inside such frameworks can grant high speeds to objects. If Oumuamua did indeed come from a paired framework, the gravitational forces from the stars might have impelled it on its interstellar excursion. Making sense of its wonderful speed, past its speed, studies have disclosed fascinating subtleties about Oumuamua's arrangement. It highlights a thick external layer likened to a grandiose shell made of carbon-rich materials, cemented by infinite radiation during its broad process through interstellar space. Underneath this protective outside, Oumuamua reveals its surprisingly thick inner nature, essentially made out of rock, perhaps containing metallic elements. What separates it is the absence of water or ice, distinguishing it from normal comets or frosty heavenly bodies. Moreover, Oumuamua's surface has a reddish color, a consequence of drawn-out openness to inestimable beams north of a huge number of years. Several people have called for contributions from eminent specialists like Neil deGrasse Tyson and Michio Kaku regarding Oumuamua. Strangely, Neil deGrasse Tyson avoided commenting regarding this situation until significant evidence and the new declassified photographs opened up, leaving everybody anxiously expecting his perspective. Several specialists suggest that Oumuamua's prolonged structure derived from its light bend shows that it very well may be a part of a larger body. If Oumuamua severed from a larger object due to an impact or other savage events, it could have acquired significant speed during the detachment process. This would suggest that Oumuamua's speed isn't characteristic for its nature, but rather a consequence of previous events. Examinations can be drawn with comets and space rocks in our nearby planet group, which navigate at different speeds. While certain comets can achieve speeds equivalent to Oumuamua, They often show residual gas and dust due to their volatile composition. In contrast, AMU showed no such attributes, distinguishing it from known cometary objects. Likewise, most space rocks in our nearby planet group move at considerably slower rates than Oumuamua. The typical orbital speed of the notable space rock series, for example, is approximately 17,800 kilometers per hour, under a fifth of AMU's estimated speed. This dissimilarity highlights the unique nature of AMU's speed and its differentiation from organic nearby planet group objects. Some specialists speculate that Oumuamua could be more than a naturally occurring object. They suggest that it could be an artificially created creation, carefully made by a high-level extraterrestrial civilization. According to this hypothesis, AMU's remarkable features could serve various functionalities. Its stretched construction could enhance its stability during interstellar travel, while its propulsion system could enable precise maneuvering through the universe. Figures like Avi Loeb, an Israeli-American theoretical physicist and cosmologist, unequivocally support this hypothesis. Loeb even proposed a controversial theory that Oumuamua could be of extraterrestrial origin, suggesting that it may be an artificial object or even a piece of alien technology. He argued that its unconventional properties like its prolonged shape and strange acceleration could indicate an artificial origin. Loeb's theory sparked widespread discussion and debate within mainstream scientists, noting that many fundamental researchers and astronomers have expressed doubt about these claims. The prevailing view among most scientists is that Oumuamua is scientifically a natural object like a comet or an asteroid, with its strange properties being the result of natural processes. Wesley C. Fraser and other researchers used combined brightness measurements from multiple telescopes to analyze its rotation period. They concluded that no spin period can account for the observed brightness variations. Instead, the object appears to be tumbling in an excited rotational state, a motion unlike anything seen before. This irregular rotation has baffled scientists since its discovery. Observations by astronomers have provided valuable insights into Oumuamua's rotation. It completes a full rotation every 7.3 hours, which is relatively fast compared to the rotational times of other objects in our nearby planet group. Moreover, its brightness changes significantly as it turns, showing that different parts of the object reflect sunlight to varying degrees. This irregular rotation has bewildered scientists and led to various interesting theories. One theory proposed to make sense of Oumuamua's turn is the spin-induced outgassing hypothesis. According to this idea, unpredictable substances underneath its surface are exposed to solar radiation as the object tumbles through space, causing it to disintegrate and create small gas jets. These jets act as engines, imparting a force on Oumuamua and causing it to turn erratically. Another theory suggests that Oumuamua's tumbling motion could result from an earlier impact with another object. It is possible that a rapid impact distorted its shape and set it into an irregular spin. However, the exact nature of such an impact and the object involved remain speculative due to limited observational data. Detailed examination of Oumuamua's shape, structure, and surface features could provide clues supporting these theories. To better understand AMU's unique movement, let's examine other celestial objects with similar behaviors. One such object is the asteroid 4179 Totatus, found in 1989, which displays a tumbling motion much like Oumuamua. Scientists have proposed several theories to make sense of Totatus's whimsical turn, including the YORP effect. According to this effect, sunlight applies a force on the object due to uneven thermal radiation, gradually altering its rotation and leading to its irregular tumbling motion. Another example is Comet 67P/Churyumov-Gerasimenko, often called 67P, which too features irregular rotation. Scientists discovered 67P on September 11, 1969. This comet orbits the Sun and displays a striking shape and peculiar construction, featuring two distinct lobes connected by a narrow neck. It belongs to the Jupiter group of comets, indicating that its origin can be traced back to the Kuiper Belt, a region beyond Neptune populated by cold bodies. However, scientists believe that gravitational perturbations caused by Jupiter's massive gravity trapped 67P into its current orbit. Regarding Oumuamua, Scientists trust that the outgassing and interactions with sunlight might have caused the strange acceleration and tumbling motion observed. Continued study and observation of Oumuamua and similar celestial objects will likely provide further insights into their nature and behavior, shedding light on the mysteries of the universe. Of unpredictable substances from its surface assumes a huge part in its tumbling movement. As the ice on the comet's surface disintegrates affected by sunlight-based radiation, it makes confined jets that carry on like engines, adjusting the comet's revolution. The similitudes between Oumuamua and these articles allude to potential basic components answerable for their surprising twists. Further investigation and point-by-point investigation of these items can give valuable experiences into the nature of Oumuamua. The origin of Oumuamua has likewise been a subject of perfect hypothesis. Several scientists proposed that it could be a piece of a larger body shot out from its home star system due to gravitational interactions or a horrendous event. This discharge may have conferred an initial twist on Oumuamua, which has persevered all through its interstellar excursion. The specific process by which Oumuamua was catapulted and its ensuing direction remains uncertain, highlighting the need for additional data and further exploration. However, there is plausibility that Oumuamua is a side effect of an impact between two objects in a far-off star system. The subsequent debris could have been flung into interstellar space, with Oumuamua being one of the pieces trapped in our nearby planet group's gravitational draw. Without further evidence, these hypotheses remain speculative. Detailed examination of Oumu's composition, isotopic ratios, and surface features could provide clues about its origin and shed light on the mechanisms involved in its curious twist and movement. As displayed in these pictures, the absence of apparent emanations bewildered researchers significantly more. This exclusion of visible discharge eliminated the possibility of Oumuamua being a typical comet or asteroid and presented an intriguing riddle that required further investigation. There is plausibility that Oumu's absence of emanation could be made sense of by it being a dead comet. A typical comet's icy composition disintegrates as it moves toward the sun, resulting in an emanation trail. However, if Oumuamua had lost most of its volatile materials due to repeated close encounters with stars in its long interstellar journey, the absence of apparent emanation could be accounted for. Intense radiation from these encounters might have stripped away Oumuamua's volatile components, leaving behind a rocky or metallic body without the typical coma features. This provided space for the possibility that Oumuamua is an interstellar asteroid. If Oumuamua were a space rock, the absence of apparent emanation could be made sense of, as space rocks generally don't display the same outgassing behavior as comets. However, the elongated shape of Oumuamua remains a mystery, as space rocks in our solar system generally have more irregular shapes. Some scientists suggest that the elongated shape could result from gravitational forces experienced during close encounters with a star or a planet in its parent star system. Also, the asteroid Bennu, the target of NASA's OSIRIS-REx mission, provides an interesting comparison. Bennu, classified as a primitive carbonaceous asteroid, did not show any apparent emanation during its close encounters with Earth. However, this absence of visible discharge was expected, as Bennu's surface was predominantly rocky with minimal volatile content. This demonstrates that asteroids, unlike comets, generally don't show visible discharge, aligning with the idea that Oumuamua could be an interstellar asteroid. What were Neil deGrasse Tyson's perspectives on the declassified pictures? After releasing the declassified pictures, Neil deGrasse Tyson took on the responsibility of actively investigating and figuring out the details and potential implications of Oumuamua. Neil deGrasse Tyson consistently emphasizes the importance of evidence-based inquiry in his discussions on Oumuamua. He highlights the need to approach the topic with skepticism while exploring the fascinating idea of Oumuamua as a message. This approach reflects the essence of scientific inquiry, where extraordinary theories are conceived, tested, and either validated or invalidated. Tyson suggests that the universe may be far more mysterious and complex than our current understanding. He also considers Oumuamua as a test that checks our technological and scientific advancement. How we perceive, study, and respond to Oumuamua could provide valuable information to its creators about our progress, development, and readiness for potential contact. This perspective extends beyond the physical object and raises broader questions about our technological and philosophical readiness to understand and interpret such anomalies. Tyson proposes that Oumuamua's sudden appearance and the resulting scientific activity it set off should be viewed as a test about our technological capabilities. The fact that we could detect, track, and analyze it demonstrates our growing abilities in space observation and exploration. Furthermore, Oumuamua challenges our scientific models with its surprising acceleration, remarkable shape, and trajectory that defy simple explanation. Tyson sees this as a test of our scientific adaptability. Could we ever adjust our theories and models to accommodate this new data, or will we try to force it into previous frameworks? Oumuam's brief passage through our planetary system required swift, coordinated efforts from the global academic community. Tyson considers this to be a test of our ability to collaborate, share knowledge, and pool resources in the face of a sudden and unexpected cosmic event. It raises the question of how we responded to this test and what lessons we have learned to prepare for future celestial visitors. Delving further into the test hypothesis, Tyson speculates on the broader message behind Oumuamua. If it was intentionally sent our way, perhaps the test isn't just about detection but interpretation. Could we ever grasp a message or signal embedded in its structure or behavior, and if so, how would we respond? These questions remain unanswered, and the search for answers continues. Another perspective Tyson explores is the actual trick of Oumuamua as an interstellar messenger. Rather than being a mere test or curiosity, might it ever be a vessel carrying envoys from a distant star system? While this hypothesis might seem like science fiction, Tyson argues that we should consider all possibilities, no matter how improbable they may seem. After all, the universe is vast, ancient, and full of wonders yet to be discovered. Tyson's notion of Oumuamua as either an interstellar curiosity or a simple astronomical coincidence demonstrates the depth of his scientific inquiry. His approach blends wonder, skepticism, and rigorous scientific investigation. It challenges how we might interpret life in the universe, the nature of celestial objects, and our place in the vast tapestry. The implications of Tyson's theories are vast, ranging from technological advancements to philosophical introspections. They disrupt conventional astrophysical theories and potentially reshape our understanding of the universe. If any of his theories hold, it would mark a significant paradigm shift and propel us into a new era of space exploration.